and I want to welcome all of you here for the Zurich lecture for this year. So for those of you who don't know, the Zurich Financial Services Distinguished Visitors Program on Climate Change allows the Bren School to attract international leaders in environmental policy, law, business, and science to enrich and expand the intellectual life of the Bren School community and share insights on issues critical to climate change. And this year, we have the honor of having Dr. Charles Godfray with us. Dr. Godfray is a faculty member in the Oxford University Department of Zoology. He's a population biologist who has broad interest in science and interplay of science and policy, and his research involves experimental and theoretical studies in population and community ecology, epidemiology, and evolutionary biology. He has a particular interest in the relationship among food production, ecosystem services, and biodiversity, which will be the topic of his talk today. Dr. Godfray chaired the lead expert group of the UK Government Office of Science's Forecast Project on the future of food and farming. He's a fellow of the UK Royal Society, and as Hope Professor, he directs the Oxford Martin program on the future of food. So we've asked Dr. Godfray to give a talk of about 45 to 50 minutes. There will be a 10-minute block afterwards for question and answer. We understand that because of the late start, some of you might have to go, but we would like to ask you to kind of hold all questions until the end. So without further ado, Dr. Godfray.
Thank you very much indeed. It's an enormous pleasure to be in Santa Barbara. I had the privilege of leading a program run out of the UK Government Office of Science called a program called the Foresight Program, which takes issues of social and natural science policy relevance and spends a year or 2 years. We spent 2 years working on some of the issues concerning food security. And we reported a couple of years back, and what I'm going to be talking today is based on that, but also looking at some of the things that have happened since. Now, as I said, I'm going to do three things in this talk. First, I want to give a bit of background and some context into at least my take on what the food system is. I know many of you have thought a lot about it. I then want to do something on the concept of sustainable intensification, more of a policy issue. One of the conclusions we came from the Foresight Report was this is a way of organizing our thinking about part of the challenge of food security. And I want to explore some of the issues there. Then the final part is a sort of more pure research part. And I'd like to tell you a little bit about some work that's been done, of which I'm involved, but is led by a group from our Department of Public Health in Oxford, actually trying to couple a whole series of different models to look at the effect of climate change on human health. So, as Kyle said, I'm a population biologist by background, and I suppose the founder of the field of population biologists was the slightly unpleasant upper-class English vicar that is Thomas Malthus, who, round about the end of the 18th century, was terribly worried. He was worried about the French who were revolting. He was worried about women who were getting uppity. It was the time of Mary Wollstonecraft. He was terribly worried about the working classes who were having far too many children and things. But he was the first person who really understood the power of geometric population growth, hugely influential on Charles Darwin. Darwin says that reading Malthus and reading Lyell were the two greatest influence on him thinking about natural selection. And Malthus predicting, at the end of the 18th century, he was predicting that by the middle of the 19th century, there would be catastrophic famines in Europe. And of course, that didn't happen. It happened because of the Industrial Revolution, which increased output, and in particular, dragged people off the land to increase agricultural productivity. So I think there have been three waves of Malthusian pessimism. The first wave from Malthus himself, and then the wave in the 1960s and 70s. And I tend to sort of think of the sort of really critical document here is Paul Ehrlich's The Population Bomb. Certainly to me, I'm in my mid-50s. Reading Ehrlich when I was in my 20s was one of the most influential things I ever read. I reread The Population Bomb last year. It's an extraordinary document, reading it through modern eyes. Very dictatorial and coercive in its recommendations for population control. And Ehrlich was predicting by the turn of the century, literally, that democracy would no longer exist in Europe, that the famines that one would expect to see in Africa were far, far greater than turned out. And of course, the reason why that we dodged that bullet was largely because of the Green Revolution, the astounding advances that were made in crop breeding. And we're going through a period at the moment of what might be called a third wave of Malthusian pessimism. I'm going to talk a little bit about that more. And I think the real issue is that, is Malthus going to be right? Are we actually going to find some vindication of Malthus, or will there be a new revolution? And that's some of the things I want to explore within this talk. And so why food has gone up the policy agenda has really been the issues of price volatility that we've seen in the last 5 years. So this is the FAO, the Food and Agriculture Organization, price index. They started in 1990, but you can extrapolate back. And it was largely, we went through a period of essentially 4 decades of low and relatively stable food prices, which began to spike in 2008. I put both the real and the nominal FAO food price index there. The real is deflated by the US inflation figures, and there's some evidence that actually if you're someone living in a big African city, deflating by the US inflation rate doesn't actually give you what you experience, that the true food price cost. Anyway, 2008 we saw a food price spike, fell a bit, then it peaked again in 2010. And we can see at the moment in that we're going through a period of the food prices are coming down. There's been the economic response you would expect from increasing food prices. More crops have gone into the ground. And we've had a series of good harvests. We've had good growing conditions over the last couple of years. Now, the FAO Food Price Index have only been calculating for 20 or 30 years. I think it's also worth looking at what food prices have been doing over a longer period. This is US corn prices going back over 100 years. And one can see that food prices have been coming down. In fact, if one looks at the fraction of our income that we in the rich world spend on food, I think it's 9% in the US, it's 10% UK, probably at no time since money was invented has a society spent less on food than we do today, at least in the rich world. So we've had a period of food price volatility, but of course and I won't go into it, we could talk about in questions if people are interested, it's still highly contentious exactly what was responsible for the food price volatility over the last couple of years. But of course, the interest is, and the important question is, what are the underlying market fundamentals? What are the broad things that will affect the secular trends, food prices? And of course, there's some very clear demand and supply side things going on. With the demand side is we're seeing an increase in population. And of course, what we're experiencing at the moment is a demographic transition. Global fecundity is going down, although there's huge uncertainty around it. This is the latest projection from the UN Population Division and their median fertility assumption. So they project population going ahead, making different assumptions about how fertility trends may go over the next few years. And their median fertility assumption is the best guess. And if they're right on that, then we're expecting global populations to asymptote by the end of the century round about 10 billion. So of course, this is the extraordinary thing that even going back 40 years ago to the period of Paul Ehrlich and things, one couldn't anticipate, or one didn't anticipate, one didn't have the knowledge to know about the potential of the demographic transition there. So this is the possibility that Malthus is not necessarily correct in the end. I think one of the worrying things is that if you look at the UN Population Division's estimates over the last couple of years, they have been creeping steadily up. If you went back over 5 or 6 years ago, they were predicting populations asymptoting with the median fertility assumption round about 9.5 billion. And it is clear that the demographic transition in sub-Saharan Africa is not happening as fast as we thought a few years back. So I find this incredibly optimistic. In my mid-50s, I'm more optimistic than when I was in my early 20s because of the demographic transition. But I'm slightly less optimistic than I was a few years back. But of course, it's not just the number of people, it's what they consume. And one of the reasons we're going through the demographic transition is that people are getting richer. But of course, richer people demand a more varied diet, and a diet that takes more resources to produce. And I'm using here some of Dave Tillman's statistics of where he's related per capita calorie demand, both directly and indirectly through meat, as a function of per capita GDP. And many of you will know Dave. He's done some really fabulous work in this area. So we're going to have more people, they're going to be richer, and an indication of this is the demand for meat. Demand for meat in developed nations is relatively constant. Interestingly, in Europe, it's beginning to go down a little bit. In China, we can see a convergence of diets upon a more Western model. Again, interestingly, in India, which is going through a relatively similar development pathway, the diets are not changing for fascinating cultural, religious reasons, and also the structure of the retail section in India. So on the demand side, we're going to see secular increases. And then on the supply side, there are hugely concerning issues about the sustainability of agricultural production. And again, I know many of you are very familiar with this, so rather than sort of dwelling on what is a series of really concerning bad news, I'm just going to sort of summarize very, very quickly some of these issues. So, of the water available for man, a large amount of it is used for agriculture. On average, 70% is used for agriculture. Much of it is taken from underground resources. These figures are all slightly rough, but a quarter of vegetated land suffers some form of soil degradation. 30% of greenhouse gas emissions come from agriculture. Approximately half of that directly from food production, half of it from land converted for agriculture. Agriculture, the main source of nitrates, the other pollutant, and most fisheries are overexploited. So again, I go through this quickly because I know that many of you are very familiar with these issues, but some real concerns about the supply side and our ability to produce food at the rate we're producing, let alone at greater rates in the future. And of course, climate change will have effects itself on agriculture. This is it's based originally on World Bank numbers, but it's from a paper by Tim Wheeler and Joachim von Bren in Science a couple of years back, looking at potential effects of climate change on crop yields. So in most places, especially in the northern higher latitudes, there will be some positive effects. But in most places, climate change is going to reduce yields. There have been a series of integrated assessments trying to measure the effects of climate change. And again, slightly concerning, as the evidence gets better, as we understand some of the complexities and nonlinearities, whether CO2 fertilization may actually do something good, then the more recent integrated assessments give us more things to be concerned about. Just mention here what I think is a really rather interesting series study by, just looking for a pointer there, I don't need one, a project called AGMIP, the Agricultural Model into Comparison Project, which is taking a series of models involved in different parts of the food system. These are economic models. And here what they've done is they've taken 9 models. I think 4 are computable general equilibrium economic models, 5 are partial equilibrium models, and run them for a series of climate change scenarios out into the future and ask what difference might this make to food prices. So what extra difference might climate change make to food prices? And these are box whisker plots that show the mean and the median and the variance of the predictions for these different models run for different scenarios. And again, I know there are economists in the audience who will understand some of the heroic assumptions that need to be made to get these models to work, but they are our best means at the moment of asking some of these complex questions. And so what the models tend to predict is that climate change will reduce yields. The models tend to predict a big aerial expansion in agriculture. This concerns me hugely. But anyway, in this modeling exercise, the overall effect on production was not a lot. The aerial expansion tends to compensate for the reduction in yields. Trade and consumption stays pretty much the same, but they predict quite significant price increases. Now, of course, one of the things that they're predicting is that wages and incomes are going to go up, so there will be more people able to afford the higher food prices. But it is suggesting that the period that we've lived through of the last 40 or 50 years of declining food prices may be reversed. And although overall the world will be richer and will have more resources to be able to buy food, that overall picture hides a lot of the granularity and a lot of the difference. And I'll just finish this section by making one point along those lines. This is a fraction of the global population that are living in cities. And a couple of years back, of course we don't know exactly when, but the global population became more than 50% urban. So now more than half the world's population live in cities. This is an extraordinary figure I'm just going to pick up. Again, it's from the World Urbanization Report from the UN Population Division. These are the big cities in the world, and the colors says whether they are increasing or decreasing. So the yellows and the greens are pretty much stable. But look at sub-Saharan Africa. Look at those cities that are increasing year on year by 3 or 4%. A couple of them, Ouagadougou, increasing 6 or 7% a year. We're having these really big urban centers. It is inconceivable that many of these megacities in Africa are going to be able to be fed by local food production. That food production, the local agricultural system just won't be able to transition that fast to do so. So these cities will be relying on global commodity markets in order to feed them. And here's some data from the FAO about the developing countries and trade in cereal. So if you look at developing countries and ask how much does the bloc of developing countries export, then there are some nations, quite a few nations, that actually have a surplus in grain and are exporting. But overall, the vast majority of developing nations are importing grains from global commodity markets. And so I think the lesson for this is that relatively low levels of volatility that we in the rich world would make little difference to our incomes. So one of the projects that we've been doing in the UK with some of the financial institutions, in fact with some other insurance companies, not particularly with Zurich, is looking at some of these flashpoints in the global food system. We'll continue to have issues with hunger and undernutrition, and simultaneously obesity and overnutrition. I'm going to come back and talk a little bit more about both of them in the third part of the talk. Again, I won't repeat the litany of concerns about the sustainability of agriculture. So that's an update on some of the issues that we talked about in the Foresight Report. And in the Foresight Report, what we tried to do is to take a food system approach where we looked at all the components of the food supply, food demand, and food governance. And all the issues we looked at through the twin prisms of sustainability, the fact that we needed the food system that can continue producing food into the future, as well as the special needs of the poorest sectors, especially the poorest developing countries. And because this was a project that was sponsored in particular by government, that was looking for where policy interventions were required, we were paying particular attention to where there were market failures and where there was a need for policy intervention. And what I'd like to do in the second part of the talk is to discuss a little bit the issue around how we try to organize our thinking about the policy response to the supply side issues and future food security. And we did this around the term sustainable intensification, and that we were arguing that we needed to increase production from the existing agricultural footprint, but produce production in a way that was environmentally sustainable into the future. And we weren't the first to talk about sustainable intensification. A report that came out of the Royal Society, our National Academy in the UK, had done something similar. Actually, the National Academies of Science and State done the same thing. The top right is a French report. Interestingly, parts of the agricultural private sector have also taken up sustainable intensification. You can't read this in detail, but Syngenta, one of the big companies there, Monsanto, has done something similar, have said that they are treating sustainable intensification as an organizing principle. This is a really interesting booklet produced by the Food and Agricultural Organization called Save and Grow, which is explicitly thinking about sustainable intensification within a low-income context. And I suppose perhaps naively, as a boneheaded natural scientist, I thought sustainable intensification was sort of motherhood and apple pie. What could be wrong with it? And so was a bit surprised when I gave a talk at the Royal Society. It's the only time I've given a scientific talk where I was picketed. And there were literally picketed people from Compassion and World Farming who said sustainable intensification is an evil. And I had long talks with them afterwards, and the word intensification is defined within the animal welfare community as an inherent evil. Friends of the Earth can sometimes do some really interesting documents. They produced a document called An Analysis of Sustainable Intensification in Agriculture, a wolf in sheep's clothing. This was actually, at least in my opinion, a pretty awful document. It was largely a diatribe against genetic modification, which was interpreted as pretty synonymous with sustainable intensification. Now, many of you have worked in the policy area much, much longer than me, and will sort of recognize the naivety of my part. I think we as natural scientists like me tend to think that it's the concepts that matter, less so than the words. So in the second part of this talk, I want to talk a little bit about sustainable intensification and whether it's a concept sort of worth maintaining, and some of the issues of translating ideas like that into the policy arena. And we got together a group under the auspices of the Oxford Martin School to explore some of these issues, and we had a policy forum in Science about 18 months ago that sort of gives more details of what I'm about to talk about. And what we tried to do in that policy forum was to explore why people were reacting so badly against sustainable intensification and how their concepts and interpretation of the topic differed from ours. So we were trying to set out what we thought were the principles of sustainable intensification and how it affected how other people interpret it. Now, much of the concern about sustainable intensification was that it was a silver bullet, that it was the term that has often been used against it is that it is a purely productionist approach to food security. And in fact, if you look back at any of certainly the Foresight Report, but the other organizations that had argued for it, then almost universally, they set sustainable intensification within the argument that action is needed on all fronts. So yes, you need to do something about demand. You need to reduce waste. You need to improve governance. But that we don't have the luxury of pretending that only one element of the food system, policy attention to only one element of the food system is going to be sufficient. So our argument that one of the basic premises underlying the call for sustainable intensification, that action is needed on all fronts, including producing more food. And that sustainable intensification should not be seen as a purely productionist silver bullet. And in fact, you could argue that what you want for sustainable intensification is not direct bolstering of production now, but putting in place the policy interventions such that the agricultural system is better able to respond to price signals and better able to respond sustainably. So again, looking at issues where the market failures may be that the agricultural sector is too slow to respond to price signals, in particular will respond in an unsustainable way. So the first of what I call the 5 premises underlying the call for foods for sustainable intensification, that it's one of many things that needs to be done. It's not an argument that you purely need attention. Now, many people are arguing that what we need is a form of agriculture that is more extensive. Now, you can have a more extensive agriculture, more extensive lower yield agriculture, either if you reduce demand or if you increase the area under agriculture. The argument we tried to make very strongly within the Foresight project is that essentially, for a good approximation, there is no new land for agriculture. Now, that's not exactly true, because you could plough the Amazon, you could plough the Congo Basin. And actually, if you look at some of the economic models, including some really quite major economic models that are used by policymakers, and you delve into what the sort of assumptions are hidden in the complicated elasticity function, that is actually what these models are predicting. But I think the argument is that the greenhouse, as Stearns in the in his report on economics and climate change, as he quipped, the most efficient way of getting carbon dioxide in the atmosphere is to cut down rainforests or to drain swamps and things like that. So yes, you can convert land to agriculture, but if you do, you suffer a really bad greenhouse gas emissions hit, as well as issues with biodiversity. And again, I know some of you are experts in this field. It is really complicated actually to work out exactly how much land is available in these different categories. And some of the arguments about how much land is available for agriculture boil down to what one considers land is in agriculture as opposed to degraded land. I think the argument we're making is that conversion of pristine land or land that's been out of agriculture for a long time into agriculture, essentially, as much as possible, should be stopped. But that doesn't mean that that restoration of agricultural land shouldn't be a priority. And of course, not only is there unlikely to be a lot of new land for agriculture, land is being used for other purposes, for urbanization, and also for doing things such as biofuels. And I'm going to say no more about biofuels at this stage because I start frothing at the mouth and men in white coats come and drag me off the stage. So that's the second of our assumptions that we argue underlying the call for sustainable intensification. If you look at why many of, especially the environmental organizations, worry about sustainable intensification, is they look at sustainable intensification and they see it's essentially intensification. Be honest, if you look at some of the response for the agricultural industry, then their argument about what sustainable intensification is pretty much business as usual with marginal increases in sustainability. I would argue that if you take sustainable intensification seriously, as its originators want it to be, then it's a genuinely radical thing. It means producing food in the way that is qualitatively different from what we're doing, paying hugely more attention to sustainability than exists at the moment. And I think one of the major policy challenges, especially in Europe, I suspect also in America, is how we use the money we put into rural economies and into environmental protection, how we get better returns on our investment I think that means a much more geographical focus in some of the money that we put into it, something which is extraordinarily difficult to do within the way we organize agriculture in Europe. And finally, much of the concern about sustainable intensification, and this was underlying both the NGO responses I mentioned at the beginning, is that this is trying to bring in particular forms of agriculture by the back door, whether it's intensive livestock production, whether it's genetic manipulation. And again, if you go back to all the people who've argued for sustainable intensification, then it's agnostic, it's clear about a trajectory, it's clear about a goal, but agnostic about a trajectory. And then the final thing, again, looking at the issues about why sustainable intensification has become so controversial, has been that many people who care deeply about animal welfare, so nutrition and diet, any of those things, see it as a competing agenda that takes policy attention away from what they care about most. The animal welfare people will just worry about sustainable intensification, not welfare. And I think this is a real challenge, and it's a challenge for many other areas of science into policy, is that how you avoid the sort of destructive competition between good guys trying to argue about important things. And perhaps I've done it wrong by putting sustainable intensification in the middle. It shouldn't be in the middle. It should be one of an amalgam of different things that somehow work together. Okay, so that was the second part. And then my final part, in the last 10 minutes, I want to sort of switch from some of these broad issues to talking about a little bit of straight research that's come out of the Oxford Market Programme in the Future of Food. And it's partly, I was involved in a UN panel looking at food security and climate change. And one of the frustrations that we had in producing that document was that much of the integrated assessments and much of the literature that was trying to look at the consequences of climate change really stopped at the farm gate and wasn't looking at the follow-ons to the consequences of what we eat and the consequences of what we eat on health. And I want to describe a little bit of work that has been done by a group, as I said at the beginning, led by three guys whose name I've put up there from our Department of Public Health in Oxford. And it's a collaboration also with the International Food Policy Research Institute in Washington, who are one of the people who have a major partial equilibrium model of the global food system, quite geographically structured. And their model is called the impact model. It's particularly neat in that it interfaces with global climate change models, and they have quite a sophisticated hydrological model as well. It's not quite an integrated assessment model, but it's an economic model that is driven by physical drivers as well as by economic. And what we have done in Oxford is we've taken that model and we have linked it to a model that these guys have produced that is able to take a diet and in a really neat evidence-based way take that diet and says the consequence that it has for health. And the results I'm going to show you is measuring the consequences of health in terms of diet-related deaths. And what they're working on at the moment is a slightly more sophisticated version that looks at disability-adjusted life years. So I'm going to go through no more of the details than that, just to say that there's an economic model, it's driven by biophysical effects, and then it's linked to a public health model. I'm just happy to talk more about that, but I want to go straight to the results. Interestingly, the impact model traditionally had made predictions about the effects of diet change and markets on total calories coming in, although what we've done is we've found some issues with that, and so the impact model updated some of the issues of the impact. So the figures there are for the average kilocalories, the average amount of energy taken in by going into the future. So at the moment, the average calories consumed by someone on Earth is just over 2,800. The orange bar is the prediction for 2050 with no climate change. And you can see that calories are going to go up. This is partly because of the demographic transition and people getting richer. They're going to be able to afford a better diet. So again, as Amartya Sen and others have pointed out, people tend to be hungry because they can't afford food, not that there isn't food there. So this is, we must remember that there has been substantial progress in reducing calorie hunger over the last 20 years. It's a Millennium Development Goal that's probably going to be met. And going ahead through to 2050, we see that hunger is going to become less of a problem. But then the grey bar is what happens if you put in climate change. And there's still going to be significant success, but climate change is going to slow our ability to reduce hunger. Here is the effect on meat consumption and the effect on vegetable consumption. And the 2 points I want you to get from here is that in absolute terms, the amount of meat we eat is predicted to go up. The amount of vegetables we eat is predicted to go up. And in both cases, that rise is going to be slightly less in the presence of climate change. So there is an effect, although it doesn't look a very large amount. Let me express the data now in a slightly different way. This blue bar here is the avoided deaths that we expect by mid-century in the absence of climate change. Now, as I said, we expect populations to be wealthier, they can afford food, that then sort of ramifies, ripples through the economic system to encourage more food production. This is part of the good news. The general economic growth is pulling more and more people out of calorie hunger. And so one can say that with this assumption that there are probably 500,000 more deaths because of climate change than would have occurred if climate change hadn't existed. Let me show you where they come from. So here, this is that just over 500,000 categorized by what caused those extra deaths. And then above zero, you can see that deaths from stroke will be higher, from cancer. The category others is largely the deaths associated with undernutrition. And then the diamond at the top is essentially taking the plus and minuses away. So there's slightly fewer deaths. Now, what the model can do, it can actually go in and say, well, what actually causes these deaths? And you can show that the effects are because there are more deaths because people are eating fewer fruit and vegetables. There are slightly less deaths because people are eating less meat. There are more deaths because one of the causes of climate change is that fewer people come out of calorie hunger and so remain underweight. However, fewer people become overweight and fewer people become obese. And so what you can see is that there is a complicated effect of climate change on diets that has both positive effects, less obesity, less overweight, less meat-associated deaths, and negative effects, more deaths associated with lower consumption of fruit and veg, and because of people coming out of weight. And I'm coming towards the end of my 45 minutes, so I won't go through in detail the geographical things. I mean, briefly, the red in Africa, the bad news is because fewer people are leaving the underweight category. In Mexico and the northeast of South America, that's fewer people becoming obese. Now, there are a massive number of caveats from this study, as you can imagine. There are uncertainties in the agricultural models, especially the effects of extreme events. There are assumptions in the economic models. And actually, probably the model that we're most convinced about because of the evidence base is the health component. Even though we are predicting a relatively modest effect on consumption, climate change can still potentially have quite a major effect on the diet-related deaths. And interestingly, jumping ahead, considerably more than estimates that the World Health Organization have made so far. I think this argues again for the importance of a food system approach and for taking a coordinated response to diet. So it's not just a question of moving people out of hunger. One has to look at these other issues as well, especially overweight and obesity. So let me just conclude. I would argue that the food system, the global food system, is entering uncharted waters. The magnitude of the risks ahead require, again, I would argue, action on all fronts. I'd argue we need sustainable intensification. If you don't like the term, call it something else. I haven't talked about, well, we all work in universities. If you don't have a statement like that, and I wouldn't be allowed back in Oxford when I get home. But we do need to revert. There's a good evidence base now of the returns for investment. Thank you very much for your attention.